Hello dear students, in the last class we started the chapter units and measurements, rather elaborately I would say units, dimensions and measurements. And through this chapter so far we have studied what is a physical quantity, what do we mean by fundamental physical quantities and how many fundamental physical quantities are there in physics. Then what do we actually mean by derived physical quantity? We also saw the examples of fundamental physical quantities and the derived physical quantities. Alongside we saw what do we actually mean by fundamental units. Today we are going to see what is a derived unit. We shall see the rules of writing the units. We shall see some practical units, and if time permits we shall move on to some other topics also. So, the very first topic that I am going to have today is derived physical quantity, derived units. Now, to talk about derived units, already we have the idea of derived physical quantities. So, if I ask you an example of a derived physical quantity, hopefully in the last class I wrote speed and I wrote the corresponding unit also. Today we shall see the example. Derived physical quantity is velocity and I want to see what is its derived unit. So, for writing the derived unit I must write the derived physical quantity in terms of fundamental physical quantities, which is nothing in lower class we have studied. Velocity is displacement by time. Displacement by time. Now I know displacement is nothing but magnitude. If I talk, then I would say that length by time, and the length by time, see please the corresponding unit. For length it is going to be meter and for time it is going to be second. As such, this is the derived unit for velocity. Let us take another example, say acceleration. So, when I say acceleration, this is nothing but in lower class we studied change in velocity over time interval. Now, when I say change in velocity, then this will have the unit of velocity. So, therefore, numerator is going to have the unit meter per second over, at the denominator I have time interval. So, this is going to have the unit second. Now, if I rewrite this, this is going to be meter over second square. So, this will be the unit of acceleration. Third, if I say momentum, so momentum is a derived physical quantity and this is equal to mass times velocity of the object, and I say the unit mass I know is a fundamental quantity which has a unit called kilogram times velocity. I know that the unit is meter per second. So, this will be its unit meter per second, and likewise we can go on writing a very long list. For you, let me produce one more example which you are very familiar from lower classes. You call it as force, and force I know it is nothing but mass times acceleration, and if this is the case, then mass will have the unit kilogram times, for acceleration already you said you have the unit here meter per second square. So, I will have meter per second square. Now, you would claim, sir, in lower classes the unit of force we studied as Newton. When you say Newton, you actually mean it is kilogram meter per second square. So, in lower class you studied like this. So, either we can write this way or this way, kilogram meter per second square. Preferably we will use Newton as the unit of force. So, this is the way how we write the derived units. So, for writing derived units, we should know the physical quantities written in terms of its fundamental physical quantities. Now, let us move on to see the rules. How do we write the units? Now, the rules of writing units, we must keep these rules in mind while writing the units. The very first, for writing the units of physical quantities, we will use small case letters. We use small case letters for writing the units. The second rule says that when I write 2 units, we will not put any dot in between. For example, let me say I said kilogram meter. So, kilogram meter if I write, I will not put any dot in between. So, this is not the rule. That means no dots between units. Okay. Third, at times we will use the names of the scientist as units. So, while writing the names, if I write the name in expanded form, then it is compulsory that all the letters must be written in lower case only. Example, if I say Newton is the unit of force, and if I write in expanded form, then I will write like this. And if I write in abbreviated form, in that case I will be writing capital letter. So, I told you small case letters we will use for writing units, but as far as the names of the scientists comes as the unit, then in that case if I write in abbreviated form, I am going to use capital letters, and in expanded form it will be small letter. For example, you must have heard in lower class Pascal. So, when you say Pascal, then this is the expanded form. However, here we are going to write Pascal like this. Okay. Then you would have come across joule as unit. So, small case, if you write in abbreviated form, it will be capital J. So, therefore names of scientists in smaller case while writing in expanded form. And uppercase while writing in abbreviated form. The fourth rule is that while writing units, we will never use plural form. So, therefore, no plural forms in units. Example, I will write centimeter, but not centimeters. In no way we will use plural. So, like this, these are the rules strictly we follow while writing the units. Even in the NCERT book, if you look at by NCERT book, if you see most of the good physics books, you will see that the rules or these rules are strictly followed while writing the units. Next, in addition to these derived units, we also use some practical units. Let's see what are those practical units. So, most often you will come across like this, say 1 Fermi, you will come across 1 Fermi. So, Fermi means it is equal to 10 power minus 15 meter. So, this 10 power minus 15 meter is called Fermi. In short, it is written as small f. Next, you will come across 1 angstrom like this, and in symbols it is written as A at the top 10 like this, 1 angstrom, and this is equal to 10 power minus 10 meter. Then you will come across 1 micro, like this you will come across micro. In symbols you will find a Greek letter mu, this way they write. So, whenever micro comes, it is going to be 10 power minus 6 meter. Rather, in between these two, between angstrom and micro, we will have 1 nano also. So, if we get 1 nano, in short it is written small n, which will have a value of 10 power minus 9 meter. So, then comes fifth, we will come across 1 milli. In short, we write small m, which is going to be 10 power minus 3 meter. Then sixth one, at times we also come across 1 centi, or small c is the abbreviated form, and this happens to be 10 power minus 2. Rather, when I write meter, 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 I am talking about centimeter, millimeter, nanometer. If I wrote meter here, it is micrometer. And angstrom meter, we won't say, it is angstrom, right, centimeter. So, this way, while solving the problems in physics, the values will have been given like this, some 5 micrometer. So, what we need to do is that first we need to convert this micrometer in terms of meter or in terms of SI units. Only then we will be substituting these values in the formula that I will find suitable to be substituting. So, therefore, this we must keep in mind. Besides these, we have other practical units. The other practical units, I told you, it is light year. Light year, abbreviated as LY. Now, this light year, when I say this is the practical unit, so this is unit of length. This is unit of length. So, if this is unit of length, then which length we call as light year? It means, see please, if I have a source of light, say like this, and if I put on this light, and let me say that this light travels like this for 1 year time. Now, the moment I put on the light, from then on, for 1 complete year, what is the distance travelled by the light? I am going to call this distance as 1 light year. So, in that case, see please, I know speed is equal to distance by time, otherwise I say distance is equal to speed into time. So, when I say speed into time, the speed with which the light travels, you have studied that light travels with a speed of 3 into 10 power 8 meters per second in lower classes, you have studied. So, I know this value, speed of the light. Speed of the light is generally shown by the letter c. So, for me, V will be c, and time you said it is 1 year. So, the distance travelled will be equal to 3 into 10 power 8 into 1 year. When I say 1 year, that means this is not the SI unit. However, 3 into 10 power 8 meter per second is in SI unit, it is okay. So, I need to convert this year into SI unit or into seconds. So, I know in 1 year I have 365 days. 365 days, each day has a 24 hour and 1 hour has a 60 minute and each minute has a 60 second. So, therefore, 3 into 10 power 8 meters per second, 1 year. So, year has a 365 days, a day has a 24 hour, an hour has a 60 minute, a minute has a 60 second. If you work out these values, this value would be 9.46 into 10 power 15 meter. So, this much length you call it as a light year. The next unit, practical unit, we talk about astronomical unit. And this astronomical unit is abbreviated as AU, capital A, capital U. So, then this is also the unit of length, okay, very large unit. Now, what is this unit if it is asked? Then it is the sun, and let us say this is the earth. We know that the earth revolves around the sun in an elliptical orbit, and also we know that the distance between earth and sun keeps on changing. But when I say the average distance between earth and sun, this average distance, that is center of the sun to the center of the earth, the average distance if I calculate, that average distance I am going to call it as 1 astronomical unit. So, therefore, the average distance between sun and earth, okay, when I say sun and earth I mean center to center, okay, is called 1 astronomical unit, is called 1 astronomical unit, and the value works out to be 1.496 into 10 power 11 meter, which is equal to 1 astronomical unit. So, at times whenever in the problem for me the value is given as 1 astronomical unit, then I will be replacing this 1 astronomical unit with the SI value in 1.496 into 10 power 11 meter. Next, dear students, we classified the physical quantities into 3 categories if you remember. We said fundamental physical quantities, we saw what they are, we saw their unit, we saw derived physical quantity and its units also. One more classification we are left with, that is supplementary physical quantities, in which we studied that there are 2 physical quantities which are kept in the category of supplementary physical quantity, and they are plane angle and solid angle. So, we shall talk about the plane angle. So, this is the supplementary physical quantity and this has its own unit, So, plane angle, when we say, let us talk about a plane figure, say circle. So, when I consider a circle, let me suppose that this is its radius r is the radius. Now, from this point, let me say this point is moving on the circumference of the circle and it has reached to this point. So, let us say that this is the axis now, and let me say this is also an axis, and if I say the point has moved from point A to point B, say O is the origin. So, now I say when O moves to point B, then this is the position. Now, while the particle moves from point A to B along the circumference of the circle that has a center O, then I would say that this radius vector has subtended an angle of theta when the particle has moved from point A to B. So, what is an angle? Angle is nothing but, now you see the path through which the particle has moved from A to B, I am going to call this one as arc. You are familiar with. So, this length of arc, if I divide by the radius, then I am going to get the physical quantity, I am going to call it as plane angle. So, it is very simple, the plane angle is nothing, plane angle is equal to the arc length over radius, arc length over radius. So, therefore, see please, as the particle keeps moving, the arc length goes on increasing and the radius is constant. So, theta is going to increase, otherwise plane angle is equal to this much. Then if we talk about the unit of plane angle, is radian, In abbreviated form, we write it as RAD. So, this is how we give the SI unit of the supplementary physical quantities. This we need to keep in mind. Now, we must also keep in mind that in lower classes we have studied the angle subtended by any arc in terms of degrees. However, now we have come up to call the angle subtended as a radian. So, degree is not an SI unit, however, SI unit of angle is radian. So, we should have the relation between the two. So, that is how we say, see, 2 pi radian is always equal to 360 degrees. 2 pi radian is equal to 360 degrees. If I work out this one, if I divide 360 by 2, so I am going to get pi radian is equal to 180 degree. So, dear students, at times you may come across, you may need to convert degree into radians or at times radian into degree. So, in that case, if I look at this diagram, I shall write pi radian is equal to 180 into 1 degree, or I would say that 1 degree is equal to pi by 180 radian. So, 1 degree is equal to this much. If you are asked to convert now, say it is given x degree, you convert this one into radian. So, what I am going to do, I know that 1 degree is equal to this much. So, I am going to write this as x into 1 degree, which is nothing but x degree. 1 degree is this much. So, this is nothing but x into pi upon 180 radian. So, my answer is going to be x times pi by 180 radian. So, this is how we will convert degree into radian. But if you are asked to convert radian into degree, in that case what you would do? In that case we can reverse this one. See please, pi radian. So, we can write pi into 1 radian is equal to 180 degree. Otherwise, I shall write 1 radian is equal to 180 degree over pi. So, this is the way. So, radian is converted into degree. If you are asked to convert x radian into degree, if they ask what the value is in terms of degrees, so I would say that this is nothing but this will be x times 180 by pi degree is going to give me in degrees. So, let us see the other practical unit called as parsec. When I say parsec, this is nothing but an abbreviation of parallactic second. We call it as parsec. Now, what is this unit for? this is the unit of length. This is unit of length. Now we need to understand what's it. Now let me suppose this is a line and this is another line. Okay. Now what I say is that the two lines make an angle of 1 second. Now what is 1 second? See please, 1 degree is further divided into 60 minutes. That means 1 degree angle is divided into 60 equal parts and each part is called as minute, so total 60 minute. Further, 1 minute is nothing but 1/60th of a degree, so 1 minute is further divided into 60 part, so the smallest part we call it as second. 1 minute is converted into 60 seconds. For second we put 2 dash at the top. So that means 1 degree is equal to 60 minute, 1 minute is equal to 60 second. So that means the smallest unit of the plane angle is 1 second, and second is written as double dash at the top, and that is what I wrote here. It is 1 second. So 1 second is very small, or say 1 degree is divided into 3600 equal parts, and the 3600th part is 1 second. Now if I see this is an angle, then this angle will have an arc. Now if I increase the length, I know that the arc length is also increasing. So I am going to increase the length. When I increase, the arc length increases. So one thing is sure, that when I go on increasing this length, or rather you say this is the radius. So when I increase this length, I know that the arc length is also going to increase. Now when the arc length increases, then I will go on increasing until this length of the arc, until you say the length of the arc, for us it is an arc length. So until the arc length becomes equal to 1 astronomical unit. 1 astronomical unit. That means now for getting the arc length of 1 astronomical unit, you have to increase this length. Now the length that subtends an arc length of 1 astronomical unit, this length you are going to call it as 1 parsec. You are going to call it as 1 parsec. So 1 parsec is that length of radius which subtends an angle of 1 second with the help of an arc length of 1 astronomical unit. Rather, I would say that the distance or the size of the radius with the help of which an arc length of 1 astronomical unit, when subtends an angle of 1 second, then this length of radius is called as 1 parsec. So then the value of 1 parsec, this is unit of length we said. So now 1 parsec is this length. I know plane angle is equal to arc length, say length over say radius. But radius I told you parsec, so radius is equal to L over theta. In that case, see please, for getting 1 parsec, the size of the radius is 1 parsec. So this is equal to length of an arc is equal to 1 astronomical unit, and this is equal to theta. Theta is equal to 1 second. So I need to convert this value now. To convert, 1 parsec is equal to 1 astronomical unit is 1.496 into 10 power 15 meter over 1 second is not an SI unit. So this is meter, and 1 second, I know 1 second in terms of degree. So 60 seconds is equal to 1 minute. So 1 second is equal to 1/60th of a minute. So 1 second can be written as 1/60th of a minute. So let me put it like this, 1/60th of a minute. But I know that 60 minute make 1 degree and 1 minute make 1/60th of a degree. So if this is 1/60th of a minute, then minute can be written as degree by writing 1/60th of a degree. Now this is 1 degree. Already we have studied that 180 degree is equal to pi radian. So 1 degree is equal to pi over 180 radian. So in that case, this degree I will write in terms of radian, because I know in problems I need to substitute the values in terms of SI unit. So degree is to be converted into radian, and this value works out as pi by 180 radian. Okay. So now if we work out this value, we are going to get 1 parsec is equal to, when you work out, you are going to get 3.08 into 10 power 16 meter. So this is what we call it as parsec. So dear students, we are here at parsec. We have covered the plane angle unit. Next class we will look at the unit of solid angle steradian, and next topics we shall see. So till then, bye, thank you, enjoy, do work, thank you.